Most developers solve this problem with extra memory, but there's a hidden trick that removes the visited set completely.
Hello everyone and welcome back. Today we are solving another LeetCode problem, Jump Game 3. This problem is a very good example of using breadth-first search on arrays and graph traversal concepts. We will first understand the intuition, then optimize the solution step by step, and finally analyze the complexity. So let's get started. We are given an array of non-negative integers called array, and we are initially positioned at start index of the array. From position I, we can jump to either I plus array of I, or we can jump to I minus array of I, as long as this is within the boundary of the array. And our goal is to determine whether we can reach any index whose value equals 0. And if yes, we return true, otherwise we return false. The important observation here is each index behaves like a node in a graph. And from each node, we can move at most 2 other nodes. So this problem becomes a graph traversal problem. We can use here either depth first search or breadth first search. But breadth first search here is very clean and easy to understand. So this is the approach that we are going to solve this problem with. So we start from the given index and then explore all reachable position from that index. And we stop immediately once we find a 0. So for a breadth first approach, as everyone know, we use a queue to push element as we push element of the array that of the current index of the array. So if we start at, for example, start at position index 5, we start by adding the index 5 at our queue, and then from that index we check all possible positions that we can move to and keep adding these elements to our queue. And also we have to remember that we need to use some sort of a visited data structure, and this could be an array or a hash set. And this is the straightforward solution. We use a queue for the breadth first search and a visited array or a set to avoid infinite loops. Because without tracking visited indices, we may keep up jumping forever between positions. But here at this position, we can do some sort of optimization. Instead of using an array of hash set for the visited positions, we can store the visited state directly in the input array. And why this can solve the problem, or why this works in our problem, because the constraints here said that the constraints here that we have an array of non-negative integers, so we can safely mark visited position with negative ones. That means that as we traverse our array, if array of I equals -1, that means that this index has already been visited. So let's go through the code. First, we will define a variable to hold the size of the array. And then we create a queue and push the start index. So we will create a queue of integer, name it queue, and then we push the start index. Then we loop while the queue is not empty. We pop the current index. So while our queue is not empty, then we will pop the current index. So let's name it current, and we get the queue, the front element of the queue, and don't forget to pop this element out of the queue. And we need to check here if the current element or array of current element equal -1. So this means already visited. And here we need to continue. Also, we need to check if the array of current equal 0, and that means we are at the required we have achieved the requirement of array element that equals to 0. So in this case we need to return a true. Excuse me. Then we need to explore all the positions that we can reach from this current position. So let's name it jump, and our jump will equal array of current. So our variable jump will hold the value that we can move either to the right of the array or to the left of the array. And we need not to forget that we need to mark that index that it's already visited. After that, we calculate the new position to the right. Let's name it forward, and that will equal the current index plus the jump. And also we need to define the other position. Let's name it backward. That will equal the current position minus jump. Then we check if our forward position is less than n. Then we push this position to the queue. We check here that forward is less than n to make sure that it's not beyond the boundaries of the array. And also we check if the backward is greater than or equal 0. Also we check this position in our queue. Otherwise, if we traverse all the positions that we can move to and we didn't return true here, this condition didn't return true, that means that we can't reach a valid answer here, so we return false. So let's run this, make sure that it doesn't have any syntax error, and let's submit it. And now let's analyze the complexity. The time complexity here is O of n because every index is processed at most once. And the space complexity is O of n also because in worst case, the queue may contain all the indices. And as you know, this is a very common interview pattern. whenever you see states or possible transition and repeated exploration, think about graph traversal. And if the constraints allow modifying the input, you can often eliminate the visited array entirely, which gives a cleaner and faster code. And that's all for today's problem. If this explanation helped you, don't forget to like the video and subscribe to the channel for more problem solving and clean coding content. Thanks for watching, and I'll see you in next one. Bye.